Payments of $10,000 15 months ago and $7,000 due 6 months from today are to be replaced by a payment of $4,000 today, a second payment 9 months from today, and a third payment that's 3 times as big as the second payment in 1.5 years. What should the last 2 payments be if money can earn 6.4% compounded quarterly? Let's go ahead and set up our time diagram. I've highlighted all of our important dates along the time diagram, and let's begin with that first payment stream. The first payment stream will represent in black. We had a payment of $10,000 15 months ago, and we also have a payment of $7,000 due in 6 months from today. And what we're going to do is try to replace this payment stream with a new payment stream. I'm going to highlight these values in green. We have a payment of $4,000 today, a second payment in 9 months. We don't know the size of that one, so let's represent that with the variable x. And then we have a third payment 18 months from today, or 1.5 years away, and that one has to be 3 times as large as the second. So let's represent that with 3x. Next, we need to decide on a focal point. Since there's one value at each one of our time steps, the easiest one to choose typically is the one that's the furthest into the future. This way we only have to apply future value formulas rather than present value or principal amount formulas. So unfortunately, this does mean it is going to be a 5-step process to get to our final answer. But what we're going to do is we're going to move the green payment streams forward, so our x at 9 months and our 4,000 at today. We're going to add that up with the 3x that's occurring over here at the 18-month mark. That should give us the fair market value of our green payment stream. In steps 3 and 4, we'll move the black payment stream forward to the 18-month mark. We'll add them up in order to get the fair market value of the black payment stream. And then once we do that, we should be able to compare these 2 payment streams and hopefully solve for x. Let's begin with that payment of x that's happening 9 months from today. In order to move this to the 18-month mark, our time variable must be 9/12, or 9 months. We know that we have compounding that's happening quarterly, so our frequency number is 4. Let's multiply t and f together. Doing that gives 3. So here we know that our money is going to go through 3 compounding periods in this time. And simplifying that expression, we should get about 1.048, and this is going to be the coefficient of that x variable. Next, we need to find the future value of the $4,000 payment that happens today. Well, this should go through 18 months, so our time variable here is going to be 18/12, and we know the frequency number is 4, so let's take 18/12 and multiply by 4, and that indicates to us we should go through 6 compounding periods. And when we simplify this expression, we should get a future value of $4,399.69. In our third step, we're going to look at the payment that happens 6 months from today. That payment size is $7,000. We have to move this to the 18-month mark, so that means it's going to go through 12 months worth of time. 12/12 is equal to 1. So when we multiply t and f together, we should get 4. And performing this multiplication gives $7,458.87. Finally, we'll deal with the payment of $10,000 from 15 months ago. How many months does this payment have to go through in order to get to that focal point at 18 months from today? Well, it has to go through 15 months in order to get to today, and then an extra 18 months in order to get to the focal point that we want. 15 plus 18 is equivalent to 33. So if we take 33, divide by 12, and then multiply by 4, we should get the number of compounding periods, which is 11. Performing the indicated multiplication gives a future value of $11,907.78. So now we're in good shape to compare our two payment streams. So looking at the green payment stream, we need to take the value of 3x, and we need to add to it the two future values we calculated in step 1 and step 2. And for our black payment stream, we need to add together the two future values we calculated in steps 3 and 4. Adding up steps 3 and 4 gives a value of $19,366.65. And what I'm going to do is I'm just going to fill in the information that we calculated from step 1 and step 2. And what we need to do first is we need to combine our like terms on the left side. So we're going to take the value of 3, that's the coefficient in front of our first x, and add it to our 1.04. In order to solve for x here, we are going to have to take our 19,366.65 and subtract off the 4,399.69. That should give us $14,966.96. And then, of course, our last step here is to divide both sides by the coefficient in front of the x. So let's take our 14,966.96 and let's divide by that large decimal number. And that gives x is about $3,696.67. So what does that mean for our payment streams? Well, if we go back to the statement of the question, we're actually trying to find two different payments. We're trying to find the size of our last two payments. So the payment that happens at the 9-month mark and the 18-month mark. So our final answer here should not only be the value of x, which is $3,696.67, but also what's going to be the value of that final payment, and that should be 3 times as much, which is $11,090.01.